This thing, I will give you co-host. Okay, and there you go.
Cool. Let me go ahead and,
And we are live streaming.
great. Let me go ahead and share my screen. And it worked. So today's class is maximizing the controller options for your display. Um, First things first, I just want to say thank you to all the sponsors who helped make this possible, and of course, all of the volunteers. It's been a great experience over the last couple of days. I hope everybody else has enjoyed it as much as I have. A little bit about me. This is my 5th year doing a pixel display. For a living, I oversee an IT department for a media company. And if anyone's ever used the Pixel Power Calculator, I created that many years ago, actually to help my display, and I'm glad it's helping others. So the agenda today is I'm going to really kind of go over some of the basic rules of thumb. There's probably going to be a little repetitive, but then I'm really going to get into the challenges we all face as our displays evolve, and I'll use mine as an example. And then really the point of this class is how to adapt what you already have without always having to buy new controllers or new hardware as your display evolves. So choosing a controller, kind of the general rule of thumb is have the controllers as close as possible to the props. So when you're looking at your layout, look at your prop spacing, where are props grouped, what is the pixel count of those? We have, with the advent of the high density props, we have a lot of props that are, 800 to 1,000 pixels nowadays, which obviously makes you have to look at your display a little bit different. So back in 2016, when I started, my display was really laid out, where everything was pretty much condensed. So I had the mega tree, I had the house, and my front gates. And at that time, it worked out really well to be able to just have 3 separate controllers, one for the mega tree, one for the house, and one for the gate. And that's how I ran my first year show. Now we jump forward to 2019. My display evolved, as all of our displays evolve from year to year, and seemingly my needs changed. I no longer really had a condensed area. I couldn't easily put a controller in front of my house and then run a million wires up to my roof, so I had to think about it differently. As such, I went to smart receivers. Now, in hindsight, I didn't necessarily need to, and we're going to kind of talk through that. And that's what ran my display last year. Now, jumping to 2020, again, kind of along the same theme as our displays evolved, I ended up adding this year almost 5,000 pixels to my roof. And adding that many pixels over what I previously had really made me have to take an opportunity to step back and go, how am I going to manage all of this? How am I going to control it? And how am I going to power it? And I'm sure some of you have been around for many years, kind of been in this dilemma. And I'm hoping through the rest of this presentation, we can kind of talk through that. And one of the things we have, some of the challenges, or you can call them opportunities, is we're limited by our power supplies. We're limited by the power consumption of a controller. There are options for that. We can do local no power injection, local port. I'll kind of talk through that. Receiver boards and smart receivers, and how you can utilize these in different manners to be able to achieve your particular goals. So let's start breaking it down. If we take a standard controller that you have 2 power supplies hooked up to on either bank, you're ultimately, in this example, I'm using the 3 arches as shown here on my roof, which are these 3 right here. These are the new ones from Gilbert Engineering, and each one is 839 pixels. If I was a person who did not want to do power injection, obviously and I wanted to make sure that, that I didn't have flicker, I didn't have power loss. Ultimately, I'd probably need to use 4 ports off the controller. In turn, in doing so, I'd end up using 12 ports just to control 3 elements out of my roof. The other challenge with that is on bank A, even running at 40%, I would potentially be pulling 33 amps, which the board is not designed to do. So let's kind of go through that. On a standard 16-port controller, they can drive 16 and even higher pixel counts with some of the newer boards, 16,000 pixels. Our challenge is, though, that we're actually limited to about 2,500 pixels. And that's a limitation, not necessarily of the power supply, that's a limitation of the controller itself. As such, we're only able to actually utilize 16% of that board's true capacity. Some may say I'm using a 1,200 watt power supply. You're still limited. And the reason is, again, it's back to the controller. You're not actually going to be able to utilize all of that power, that potential power you have in that power supply when it's directly connected to the controller. And we're going to kind of go through that. Again, why am I limited? You know, the HP power supply can easily drive 4,000 pixels. The board, though, is limited to 60 amps. So 30 amps on each bank. Again, that, you know, 12 to 1,500 pixels per bank. To stay within the safe range. And I'm going to pause for a second and check chat and see if there's any questions. How do I get to chat? I can't get to chat because I'm sharing.
Yeah. Someone wants to know if we can share a link to the calculator.
Yeah, they shared it. The next person shared it.
Oh, I see that. Thank you.
Okay, cool.
That's it.
Good. All right. And click over here. So early on, I realized that there was, in my first year, that there was this limitation. So, you know, being new, not really knowing what I'm doing, and just kind of fumbling my way through it, I had the concept of sending, you know, the ground and data using Speakon connectors from my controller boxes into power boxes. That way I could kind of distribute it. And it worked. It ran my show very well the first year. But when I started moving on to my second year, my third year, this design was really not optimal and really didn't work anymore. Unfortunately, I put myself in kind of a box when I first started. And so I wanted to kind of now say, well, what options do we have today? If I'm somebody per se that, you know, doesn't like power injection, we have, with the power of our smart receivers, you can actually technically run the network cable to your smart receivers, daisy chain them, essentially taking 4 ports on your controller and turning it into 12 ports locally to be able to manage and control those particular, whatever element it is. And in this example, again, with the HP power supply, because I'm no longer limited by the power of the board or its capacity, by adding these 3 receiver boards, I've essentially tripled that, giving me a capacity of 90 amps. I can now, in this type of configuration, again, with no power injection, fully utilize that HP power supply I had. And then again, only using 4 ports from my controller. You know, some of the drawbacks, obviously, it's an added cost because you've got to buy the extra smart receivers, in this case, 3 of them, to be able to control it. Because you're not doing power injection, you know, obviously at the end of each string, you will have some power loss. And the last one is because we really, and in this example, using a CLEP board, going over that 800 pixel count. So you're going to run less than 40 frames per second. Not much, but you will still be running less than the true 40 frames per second. And the next example is kind of, you know, my expertise is really power injection. So in this case, just using a regular receiver and then using 4 data ports to control the 2,500 pixels, and then power injecting essentially every couple hundred pixels throughout the entire, all 3 of the arches themselves. And I really wanted to show the 2 different options for those of you who do like to do power injection and don't mind it, versus those of you who don't like power injection. So you can achieve the same goal by either way, whether with or without power injection, and still only use 4 ports of that controller, still giving you, you know, the added capacity of the rest of them. The next one I kind of want to talk about is supplementing your controller. And this one's a little more confusing. And if I go if you think back to earlier when I was using the Speakon connectors between a power box and the controller, it didn't really work. In this particular aspect, and is removes by running the power separately from the controller, kind of similar to what we did with the smart receivers. You again bypass that 30 amp limitation. So say you were using 5 ports on the controller, sending power, sending everything as normal, and 300 pixels. When you hit that 1500 pixel mark, you could then supplement that by then running power off of a separate power supply and then removing the V plus out of the controller box itself. Obviously, you don't want to backfeed it, so you would just remove it from here. And by doing this, it becomes very modular. The way I do it when needed is I just use a power injection tee. I make them myself, and I really just put it right off the pigtail coming out of my controller box. So it's at the very beginning of the line prior to it actually traversing to the prop. Some of the drawbacks, though, again, because it's a 16 port controller, all the props need to be close to the controller. Obviously, if they're spread out, you're going to want to use receiver boards or something else. But if you have an opportunity to be able to use a controller and want to maximize it locally, you can do so in this fashion. So to kind of give it a little more depictive aspect of what I'm talking about, you can see here, I have an F16 V3 in this particular sample where I'm powering it normally on the left side of the board. I'm sending ground and data off the board itself, but right next to it at the very beginning of the string, using that power injection tee you see on the right, I'm tying in the grounds and then adding power here, removing the limitations on the board. And when you start looking at your display and, where you have, a number of high density props close by, for example, if you bought a mesmerizer this year, it's 1100 and some odd pixels. That alone is with, on a regular 350 watt power supply is going to eat up all of it by itself. This would give you that option to be able to power that and control it very cleanly and simply. I rattled through that pretty quickly. So I know I went through that very quickly, and I can go back and kind of go into detail of what I mean by any of it.
Let's go through some questions though, because I think I mean, you did go through it pretty fast, but I think there's a lot of stuff you didn't really cover that I think people are interested in.
Okay.
So let's go through the questions. So our smart receiver is also 30 amps, though of course by the 4x5 amp fuses.
Yes, they actually are 30 amps.
Can you run 3 receivers off of 1 power supply if you daisy chain them?
Yes.
Good practice is a fuse between the PSU and each input rated for the input of the board. That's an interesting one that we talk about, right?
It is. I mean, it's not. It doesn't hurt. I'll be honest with you. It doesn't hurt to fuse everything. Do you have to? No, but it doesn't hurt at all. If you're going to get a spike of higher than 30 amps that's coming through, the fuses on the board are going to blow or something else is going to happen, but it doesn't hurt at all. I used to do it on all of mine. I don't today, but it doesn't hurt.
Okay. And then Jay said, but they share the number of pixels per port restrictions that you would have if you only used 1 regular receiver.
What was that again?
It says, I guess you had mentioned something about the receivers. It says, but they share the number of pixels per port restrictions that you would have if you only used 1 regular receiver. Yeah, they still have restrictions on the number of pixels you can drive, right?
Yeah, you're limited to the port. So, I know on a Falcon, at 20 frames per second, you can run 1024. On a CLEP board, it's many more than that. At that point, you're kind of limited by power. In this particular manner right here, the pixels are the four ports are shared across the A, B, and C. So in here, so we'll just call it port 1. So port 1 here is driving 200 pixels here. Port 1 here, it's also port 1 is driving 200 pixels. And again, port 1 here is driving 200 pixels. So out of that specific port, you're actually utilizing 600 pixels off the board, just in a dispersed manner.
Okay. Let's see. So 100 pixels per port. You can run more either at lower brightness or power injection. I think what we're saying is, again, you're limited by what's the draw for each port, right?
Correct. That's your limitation, is the draw on the ports. So,
maybe talk about, how we calculate that draw, the amps, and what those numbers mean, because I think a lot of people get confused about that. And I think it's a good topic, especially when you're talking about power injection or power supplementing, why you would need that, because people throw these numbers out. You can only have 100 pixels, right? What's the limitations?
So give me a second here.
Mhm.
Let me do this.
That's
So
what I'm saying, because I think a lot of people get confused about why you need to do that. And well, let's just reduce the number of pixels so you don't have to do that.
correct. So, and a lot of people don't think about the actual power draw that's going through their board. They get it, they hook everything up, and they're going to run 300 pixels out of a port. And I've seen, some people do, some people only want 100. It's personal preference, but let's hypothetically say you ran 250 pixels off of a port. And let's change this to 0.6, because all of our pixels today are about 0.6 watts.
Yep.
You'll notice that 200 at 100%, hypothetically speaking, has the potential to draw 12.5 amps. So if the bank on the board is limited to 30 amps, at 100%, you could only potentially use 2 ports or 3 ports if you want to push it. Now, everybody, and throughout my presentation, everything was really reduced, because I know people want, they look at, I'm only going to run my show at 35%. So what does that really look like? And in this example, for 250 pixels at 35%, it's still 4.4 amps. And all I'm doing on my calculator is setting the percent and clicking the reset button, so that it gives me what the amp load would be on that. And then obviously the drop off as far as power is concerned. And I use this kind of as a gauge to say, where am I pushing my limits? Am I overdriving a receiver board, or do I need to split power up because the power supply itself can't handle it? And even though I set my display at 30%, I've overloaded it with 40 amps at 30%. So it's never going to be actual 30%.
Okay.
I hope that answered the question, or I confused it even more.
Well, I think, let's see, Eddie was the one who asked that, and then Tim said yes, and you can run more either at lower brightness or power injection. I mean, let's go to the next question and then go back to that. You can daisy chain smart receivers, but you share the pixel count on Falcons, but not the old style receiver.
Yeah, you have to use the smart receivers. But it is shared. The port is shared across all 3 of them.
Right. So this is Eddie. I asked the question if I could just kind of make myself a little clearer. So I have a Falcon F48, and I have 4 smart receivers.
Okay.
So I'm trying to eliminate having to put each receiver in a separate enclosure with a power supply. Only because I'm actually going to probably use it more in a condensed area than I had planned, just because it really doesn't make sense to do that, because it's more for a wide dispersed area, so you can go 250 feet or whatever. But in my case, I just happen to have it, so I have to use it. So I'm using it almost as I had an F16.
You are. So, and and I think this is kind of duplicative of what you're talking about,
Okay,
is that in this example, I'm only using 4 ports. So you would only be using 4 ports off your F48. Now, without power injection, you can still, as long as you're under that 680 pixel count across those total of those 4 ports, you'll be still at your 40 frames per second. So in turn, this essentially just became a 12 port controller, if you want to look at it that way.
right, right.
So you turned your 4 ports into a 12 port controller that you can use locally. Obviously limited by the pixel count, obviously, but it's essentially that's what it became.
So one more question. So the F48 is powered by a 5-volt power supply, right?
Correct.
So but I would still need a 12-volt power supply for these pixels. So I would just use a regular, 12-volt mean well or whatever kind of power supply to power those.
Correct.
Okay.
All right. Can you tie grounds of power supplies together instead of using a pigtail, and then sound power and ground from a distro board, or sound power and ground from a distro board?
You will always want to tie your grounds. And actually, no matter what, even if you're using receiver boards or any other manner, your grounds are always tied. But it's definitely best practice to tie your grounds, because when you have ground loss, you're going to have flicker. And actually, the class Keith's giving right now, if you can watch that video later, it's great. We worked on that presentation, and it give you a whole understanding of why you want to tie those grounds together. What was the other part of the question?
And then sound, power and ground from a distro board.
Yeah, that should be send, not sound.
Oh, send power. Okay. I was going to say send power and ground from a distro board. Yeah. I mean, you could do that.
That's exactly what this one is. So in this example, the data is being sent off of the receiver board, and then I'm sending all the power separately for the power injection. And the same situation here is basically separately from the controller, I'm powering a distro board and using that to send power over into the line.
So, hey, John, in that example you have up, if the power supply is powering the controller, can you just send the ground and the power from the distro board and just a signal from the controller?
Still want the ground.
Yeah, you still want the ground, and you're still, yes, you can. And actually, yes, you can.
Okay, thank you.
Let's see, going back up. Wow. Okay. Good questions. What's the wire length in the calculator?
The wire length is whatever you set. So over here, there's an option for wire length. So you can pick whatever it is.
48 can run from 12 volt as well, can't it?
No, I don't think so. I think it's 5 volt only.
Okay. Somebody said wire length. Are pixel ribbons the same as pixel lights regarding power?
What was that again?
Are pixel ribbons, so the strips, same as pixel lights regarding power? I'm trying to use several 300 count pixel 5 meter ribbons.
It's very similar. To be honest with you, it's very similar.
Can you daisy chain 2 or more differential receivers off a cult board?
Yes, I believe you can.
Yeah, I don't think there's any restrictions there.
No.
See, grounds on the V minus, correct? On the DC side.
Correct.
Do you tie the ground on the AC side with the DC side or keep them separate?
Or on the AC side? No.
Do that. I don't think you don't want to do that.
No, you don't.
There's no reason to, and it would probably not be better. Let's see. Yeah, somebody said F48 is 5 volt only. Let's see if it's a problem when differential receivers don't. Is it a problem when differential receivers don't share a common ground with the controller?
They do actually. So when they always do, the differential receivers, when you're sending through that network cable, one of the wires that's in there is the ground. So it is shared.
Let me jump into, this is Ralph speaking. I'm running a show together with my neighbors, and one of the differential controllers will be on their like power line, and the controller runs on my power line. Would that be a problem because the two houses don't share a common ground?
No, so when we talk about common ground, we're talking only on the DC side, not the AC. So the DC side from the controller to that smart receiver is shared already. The AC side is independent.
Okay, so it will work. That's what you're
Yes,
saying.
it will work.
Okay, cool, thanks.
All right. Let's see.
On the WS 2811, is the correct wattage 0.660 or 0.55?
For the pixel watts on a 12, today's pixels are all about 0.6 watts.
0.6. All right.
Yeah.
All right. Let's see. Then about lead length, smart receiver. So using more than one smart receiver board per port limits you to less than 40 frames per second.
Only if the total goes over 800 on a clipboard or 680 on a Falcon.
Okay. Yep. And then should power supply chassis grounds be tied? The
No.
game. I mean, you can, but everything. I guess you could. There's no reason why you can't.
No.
But your grounds are already tied when you're connecting all your equipment, so you don't really need to. So I think another misconception is, using this, your calculator is good, but again, you have to look and say, you've got to know what your draw is, right? And that draw is typically calculated from, again, is at full on running. So running full white, right?
That's correct.
That's going to be your draw. Well, you always have, and then even power supplies are rated, John, correct me if I'm wrong, but typically they're only showing you that 80%. There's always a 20% overway.
Actually, last year when I did the power supply challenge to see, what would happen if you absolutely maxed out a power supply,
Remember that.
not one of them would really go over 30 amps. They all stood, the Menzo, surprisingly enough, the cheapest of them all, it did pull about 33 amps when I pushed it as hard as I possibly could. But they all stay around that 30 amp is where they limit themselves.
All right. Any other questions? I think this is good, right? I mean,
yeah, I mean, the idea is to really kind of open people's eyes and say, you have options, and that are available, so that, ultimately, when you're looking at changing your display or updating, is really looking within, what you already have, and can it be used before you have to go spend money?
I got another question. This is
Sure.
Eddie again. So if I have an F16 V3 and I'm running 16 ports, isn't it true, or is it true that I can run a receiver off of that F16?
You can, off the F16 using the DMX port 1 or 4, one of those two, 1 or 4, so either one.
Does that increase? Because let's say I run another 400 off of that port, that doesn't cause a problem with the F16 with the max, as long as I'm within the 680, then, right? Per port.
So no. So what ends up happening when you do that, you have to designate which local port on the F16 is going to be used for that particular differential receiver.
Okay.
At that point, the data is replicated from those two ports. So whether that port was local or whether that port's on the differential receiver, it's the same.
Okay.
all right. Any other questions? I think that's good. I think power is one.
Yeah, I didn't want to do a whole power injection thing just because I know Bill was doing it yesterday. I mean, I don't mind answering the questions, but
Different conversation, right? I think
it is.
Bill was looking at, because I actually was watching that. I was actually hosting the room. It's the same. There's different ways to do it, right? And so what I try to do, just as an example, I have, I try to run my power. I don't run my power typically from the ends of strings, typically, because power is bidirectional, right? And so I'll run it in the middle of strings. I'll still try to run it like the first string. Sometimes I'll tie it back into the controller because that's where it's coming from. But I won't inject it like a lot of people will inject at the end of a string, right? Because they're like, oh, well, I'm at the end, I should do that. I'll do them in the middle of multiple strings because power is going to go both ways. You get a lot more efficiencies. I've run 400 pixels off of one power port.
Yeah, it's, since we have a few minutes, I mean, I don't mind talking. So
talk about the theory, because I think it's important for folks to understand that there's not just one way to do it.
So let me pull this picture up. Oh, that's not it, because it's not done yet. Here we go, this one. So yeah, to your point, Carl, is power injection doesn't have to be at the end. It could be anywhere in the chain of power. And in this example, this is the exact arch that I was referring to throughout the presentation. And you'll notice that my power injection, it's right in the middle. Also, as I've talked about before, and I think Bill kind of showed it, is between every 100 pixels, I actually just have
I put 2 packages of it.
What's
I'm
that?
wondering if I saw it and thought it would be great, and then I put it in the fridge, and then I was
Can
there.
you mute him, Carl?
Is that-
I thought it was great? And put it in the fridge.
So,
Let me find out who that is real quick. I'm not sure. Let me
Andy, Mike, you're mute.
hang on. And let me unmute. There you go. You're back.
okay. Hey, and now I have the chat. So, and so I power inject about every 200 pixels, because that way, remember, power flows in all directions. If you kind of think of like water, if you pour it into a dish, it's going to spread out. It's the same with power. It's going to go in any direction that's the least path of resistance. So wherever it needs it, it's going to flow to that, which is why I add jumper wires, is to allow that power to flow through the entire prop based upon where it's actually needed. If it's full white, everything needs it. But if I'm running a full white sweep, that the power draw is going to shift all the way through the prop. And by doing it this way, this power shifts with it and gives those pixels the maximum amount that they need. Yeah, you don't always have to, there's no hard and fast rule on where power injection needs to go.
Yep.
Where's your data starting in all of this?
For mine, it's all at the bottom left. And then I have, because I do power injection, I have it split where, like, on the first one, I'm powering 630 pixels, and then 200, and then chaining them together, another 400, and then another 600 over here, and then the fourth port's the last 600. So that way I fully utilize the receiver board.
Okay.
So here's a question. Let's see. Yeah, somebody posted this is, 0.6 watts is 0.05 amps at 12 volt. Don't get confused. Yeah, DC and AC, 2 different conversations. Running 4 total power supplies, 2 on each side of house, running 2 to 3 smart Falcon receiver boards on each power supply. Do I need to tie grounds between them if injection is not crossing supplies?
So general rule of thumb is always tie the grounds. It doesn't matter. Always tie the grounds, but you'll want to cut the V plus. You don't ever want to cross the V plus. And let me share. I'll give you an example of multiple power supplies. Hold on. So here, and you'll see here is in this example, when it's sending power and data off the controller, and then I want to inject from a separate power supply, the V plus is cut right here and then reinsert it over there. So that way you ensure that you never cross the V plus, but you'll notice the grounds are still tied together. You always want the grounds tied together.
If you can stay on that picture real quick, there was another question about power injecting up a strand like you have in that picture, which should be fine, but if you want to address that.
What was the question?
I'm not sure what the question.
Oh, sorry, I just relooked at your photo, so it doesn't actually. The question was whether you can feed backwards
Oh,
through a line for power.
Oh, because of the regulated versus resistor pixels? Is that the question you're talking through?
Correct.
Yeah, I mean, you can send from a different power supply. I would say no. From the same power supply, yes.
Resistor and regulated. Yesterday, RGB man said regulated pixels will pop if power goes the wrong way. I've run both regulator and resisted, and I've never had an issue.
Yeah.
Because power is typically going to be bidirectional. As long as your grounding is right, and you need to have your grounds tied together. A lot of that because your data is also dependent on having a good circuit. If you don't have a clean circuit, you're going to see data issues as well. Oh, regulated. You mean pop swapping? You swap the plus and minus on any string of pixels, you're going to pop them.
Oh yeah, guaranteed.
Oh, that's what we're talking about. Yeah, you never want to. You never want to do that. That's not what we're talking about here. So yeah, if you reverse your positive and your hot and your neutral, yeah, you're gonna pop something.
Yeah, that pixel's trash.
Or anything else that's in the line. So yeah, but you can power from anywhere in that pixel. Data only flows one direction though.
Correct.
Resistor may be a little forgiving. I've never seen, like I said, I run both and I've never had an issue either way. So
cool.
All right. Well, we'll go ahead and do the raffle. John, thank you very much. Really appreciate that. I think it's always good to have the power conversations because I think that is one of the most misunderstood things in our community. So thank you.
No problem. And someday I'll do a full presentation on power injection, but